making a quick tutorial on shell scripting. So I'll be assuming you have basic familiarity with terminal and some terminal commands. So let's get started. So the very first step is we're going to create a file. So let's do a hello world, so hworld. Open up in your favorite text editor. So the very first thing you have in any shell script is the shebang character. So the so sharp bang /bin/bash. This basically tells the program that, hey, this file, execute and interpret it as a bash file. So this is what you have at the very top. And another important part to understand in the shebang, in the shell script, is that it's basically a sequence of commands just like you would input into the terminal. So we can do echo hello world, we can save this file, and we can execute it. But when we execute it, you might get something that says permission denied. Well, no problem. Very easy fix to that is using chmod. And we're going to change the execution bit. So you can see over here, we have a bit, we have a R, so read, write, but we have no execution bit over here. So we're going to add it. So we're going to do user, which would be the first group over here. We're going to add the X, which is execution, and then we need to specify the file, so we go like that. And now if we do ls-l, again, we have the execution bit over here. So you can read up on chmod and how to run your files using man chmod. You can see all the different configurations you can have. So now if we do hworld, we get hello world, just like we expected. So everything is going great so far. Now the next thing we want to do is we want to try to figure out how we can do different commands. So we can call not only echo, not only use echo, but we can also use like date, who am I. We can do different commands. We can also do variables. Let's try this right now. That says who am I? Oh, who am I? We can see all of the area also gets outputted here. It's very important. So we can basically do a sequence of events over here, just like we would on any other bash command. So now let's get on to variables. So what we can do is with the variable, we can do like x equals 1. Notice how there's no spaces. Now we can echo x. Now let's try this first. So we're going to do echo x like this, where we have our x equals 1 variable over here. And then we have our echo x, and then we just write x. So what I want you to think about is what will actually be outputted when I do echo x. Well, when you first look at it, it's like, hey, well, I already declared x equals 1 over here. Let's just echo 1. However, this isn't actually what's going to happen. So if we do hworld, we're actually outputting x, which is not what we want. We want to output the value of x. So how do we do that? Well, the way we do that is we use these brackets over here. This is good for substitution. So we can actually just do $x, which will automatically substitute the variable for us. So now we get a 1. Now, in order to do a good practice, let's say we had not only x, but we also had y equals 2, and then we do something xy. Well, sometimes it can become ambiguous. So here it outputted nothing. Because it's not knowing, is it actually looking for xy, or is it looking for both x, y? So usually you tend to put brackets around these, like that, and that way it becomes less ambiguous, and the program can do the proper substitutions. So now we got 1, 2. Okay, so it's very important to understand the concept of using the curly braces, and it's a good practice to put the curly braces around it to make sure that you don't get any ambiguous cases, and make sure you always define and make it very easy for the programmer to read and understand how you're going to interpret the variables. So now let's use I'm gonna switch over to a app like this, so I can open up both at the same time. So I'm gonna switch over to oops. Okay. So I'm gonna open it in one window, and we can execute it on the other. And then I'm gonna just switch over here and click it like this. Okay. So now that I got my setup working, so let's just clear a little bit what we have over here. So we've set so far that we can have a variable x equals 1. We can also get the value of different things and store them in a variable as well. So let's try to get our current variable. So we can say the directory, actually let's try saying substituting in the variable to a different command. I think that would be pretty cool. So just like we did with echo, we can say directory equals hello. We can do ls there. So this should throw a error because you can't find the directory. You see it actually did work and it properly substituted in. So what it's doing is the shell is actually substituting in this directory variable into here and then it's running it. So ls doesn't actually do anything. This is all passed into the arguments for ls. So this is a pretty important concept to understand. So we also got some global variables that will be defined here just like in the shell. So we can do echo path. And we can get all of our path variables for everything. So let's try this. So if we head over here and we do hworld, we get our path. So this is just like I said before, just like bash. We can also get the command line arguments. Now this is a very important concept. So if we have $1, this actually gives us the first command line argument. So if we're actually running this program just like any other program, we do it like that, right? Notice how when we do, for example, echo, we pass in this string as an argument. Well, we can also do the same thing. We can read in arguments using these. We find almost like an environment variable that gets passed in. So if I do hworld hello, this echoes back hello. So when we do the $sign, there's actually variable 1 is automatically assigned to the first parameter that gets passed. Similarly, we can also fetch the file name. So we can do something along the lines of hello. I am, and you said, okay. So if we do this, it says hello, I am hworld. So this gives me the file name. So $0 gives me the file name. $1 gives me the first argument that gets passed in. Okay. So similarly, we can extend by induction. We can do this to all of the different cases. So 1, 2 goes on and on and on and on. Okay. So pretty nice. We can get all of the different parameters. These are the command line arguments that are getting passed into the shell script. We can also figure out the number of arguments that we got passed in. So to do that, we can do echo, and then we can do numbers, and we get a 1. So this is the number of arguments that we pass in. So if I do hworld hello, and pass in all these different arguments, oh, I got 4 arguments passed in. Okay. So yeah, this is the basics of passing in arguments. Another very important concept is the idea that every single program returns an exit code. So the status code of a program after it finishes. So you may know when you're coding in C++ or C, you generally do return 0, and the end will be the main method that you get invoked when you start the program, which tells the program that, hey, this completed successfully, or you do return 1 in like a Java program. This tells you that you ended with a failure. Similar idea with bash scripts and shell scripts. You can figure out what the last execution was inside of a program by putting these brackets and putting a question mark. So this tells me if there was an error in the last command that was executed. So if it's 0, there wasn't an error. You see here there was an error. You can also see how the program ended before. So if I do something like egrep, I can figure out if egrep returns 0 if the pattern was found, and 1 if the pattern was not found. So in general in Linux, we can say that 0 means success and non-zero means failure. So using this command, we can figure out what was the most recently executed command and its instructions. So the thing is, you have to be careful with this, because this is the most recently issued command. It's not the last command that, if a command failed yet, it's the last one. So if I had an error, and I want to store the error, I should store it in a variable, because the moment I do an echo, the echo will finish successfully, and then I don't actually get the problem. So let's test this out. So if I do egrep, hello, inside hworld, let's try this out. Let me just remove first this. So let's try to see if we can comment this out. Oops. Ooh, what's happening? Okay. So it looks like this didn't go through quite like I expected it to go. So let me just erase it. Figure that out later. Problem is I have these spacing issues over here. So we have egrep like that. Let's try that like this. So we have egrep, hello, each world, egrep, hello, each world. Did I save this? So it says that I passed in no arguments. So this actually returns the line. Okay, so what's happening is it's actually returning the line of where I call this. If I do each world, it's actually returning the line of wherever hello occurred, which is coincidentally inside my egrep of hello. It was actually right. Sorry, I got confused a little bit. So recall what egrep does. Egrep does a regex regular expression mapping, and then any line that contains that word that you're looking for, it actually returns it. So if I actually create a new file here called test, now hi, hello, how are you? I'm going to do a co-op term in New York again. Okay. So now I have this test. So let's try and this test. Let's search for a new. So inside test, let's search for new. So if I do cat test, I have new inside of a file. If I do hworld, it returns the file, the line containing that text. So egrep returns the expression that I'm trying to match, the regular expression, looking inside a specific file. Then I check to see if the file is found by checking the recent exit code, the exit code of the most recent command, which would be this. So what I'm trying to get at here is if I change this to that, it will not match any file, and we will get a 1, which means a failure. So this is one way of, instead of parsing the output from egrep, checking to see if it's not empty, we can simply use the exit code of egrep in order to get the result. This is very useful, and just like I said before, if we have a conditional inside of here, I will lose the result of echo because the conditional, the square brackets will be called before I do the egrep. So I'm going to lose this. So if I do echo hello inside of here and then I change this to that, this should actually return 0 because the echo completes successfully and I lose this flag. It's very important to not lose these things. Okay. You have to be very careful when you're doing this. Okay. So now we can do simple if statements. So to do an if statement, we can do the following. So we can do if. We do square brackets. Square brackets are actually apparently a command in Linux that is used. So this can evaluate the truth of a specific statement, and there's different commands and flags that we can put in. So let's just test to see what was the last value. I'm going to do something wrong here and see if you can figure out what I'm doing wrong. If you're paying attention, you can figure out. So let's just see if we actually found it. So if this equals 0, so if we actually found it, and echo found, else not found. Uppercase on. Okay. And then we do fi to end it off. Okay. So this should say not found, but observe that it actually says found. So like I said before, my mistake was I do the echo here. So the echo gets executed and it clears the last flag. So if I remove this, it says not found, which works. And now let's test it. Remove these lines of numbers like that. Over here. Works fine, and the conditional works. So we have an if, we're surrounded by square brackets, be careful to put the white space in. We use this equality operator, so we have -eq. There's different ones that you can use. So we have -eq for integer equality, We have NE for integer inequality, GT for greater than, GE for greater than or equal to, LT for less than or equal to. So I'll just comment all of these into the file. So I have my test file, so how about I just write it all over here. So if I do that, so I have less than, equal, sorry, not equal, greater than or equal to, less than or equal to, and, or, not, and so on. Okay? So those are the different commands that I can issue within these square brackets. We also have else, and then we have an fi at the end to say that we're finished, to conclude the if statement. Also, if we have an else if, it's elif. So not else if, it's elif. Okay. So now we have this, maybe we can wrap this all over into one method. So we can do found. We can actually make this one we can just invoke found like this. This is a perfectly legal argument to place. So we can make our own little functions, methods, and we can invoke it. We can also pass in parameters. And now remember, when you pass in the parameters, $1 and so on and so forth, the command line arguments also get changed. So you have to take that into account. You might lose all of your data. So when you're passing into found, if you want to pass in an argument, you'd want to invoke it into here. Okay. Now, another question you may ask is, how do I actually do an exit code? So how do I exit the program and tell other people who are using my program that, hey, this actually failed? Well, a way to actually do that is you can actually just do exit 1 inside of here, and it will exit it as well. So this is one way of outputting the error message. An even better way of doing it is actually when we do the echo, we can output this to the error stream. So recall that we have different streams dealing with I/O. We have cin, cout, just like in C++, and cin, cout. We have cerr. So we have standard in, standard out. We have file I/O, which is separate, so standard in, standard out, and then we have standard error. So standard error isn't buffered like standard out. So that way we can actually redirect this to go straight to our standard error. So we're doing this sign, like that. So this one would output straight to our standard error and will show up on the program. So if a program is designed to pipe all of the output, this will appear above of it and the user will see it. So this is best conventions to actually output it straight to standard error. Another thing to make you guys think about is if when I call this found function, does it reset this? So maybe you guys can try that out on your own. I'll leave that as an exercise for the audience. So we got that. We got bulletproofing. So now our program's pretty good. We have our own mechanism. We exit it. Do I need to exit 0 here? No, you don't. You don't need to. It will automatically be by default 0. You can also just type in exit, and that will also exit. So now let's get straight into for loops. So let's try to get some for loops going into here. So let's just do a little bit of counting. So let's do x equals 1 while x is less than our first parameter. Do echo x. And now let's increment x so we don't have infinite loops. We do something like this. And it looks like we got a small little issue here. So it looks like we got a bug. Let's try to investigate, see what the problem is. So what we're doing here is on line 18 unary operator expected. Okay. So alright, so what we're doing is we're declaring an x equals 1 variable. Afterwards, we're saying if x is less than the first parameter, do echo. Okay, so the problem is, right here, we're not actually supplying it, so we didn't actually error trap our own program. So I'm going to do hworld. Let's do a number like 20, and now we can, okay, there we go. So now we're looping over to 20. So actually, I should have error trapped my own program to figure out what was wrong with it. So we want to loop until we get to 1, so less than or equal to 1, it'll loop all the way there. Afterwards it will return 1 for the while loop, and the while loop will quit. So the while loop is flipped around, so it's not like while 1. Now here we have while 0, and flipped around, and then it will terminate the command. So another very important concept to understand here is, notice how we have these brackets. So double brackets are for arithmetic expressions. So it assumes all the variables here are stored as strings, but when you have these brackets around, it will implicitly convert it over to an integer, and then you can do arithmetic. Also notice how this x automatically gets substituted to its variable form, so you don't have x just like before when I showed you guys you could do echo x. Here when we have our x plus 1, this actually becomes an arithmetic expression, so this evaluates, reassigns it, and then it can re-execute. So if it becomes a non-legal, illegal, that's a better word to say it, becomes a legal string and you cannot parse it successfully into an integer, then it'll actually throw an error. And because this is bash, this is runtime error, so you definitely don't want that. So be careful when you're working with these sort of operations. It's very important to get this right. So we did while loop over certain numbers with a given range. We can also do something like a while loop over a list, or for loop, so like a for each loop. So we can do for file in ls do equal file done. Let's try this. We got typical error, typical rookie mistake. So let's go through this. So for each file, so we have a for each loop. So for file in, this with a single bracket executes this command, but doesn't actually output the results to standard output. I will show you guys how to redirect that later. We have our do just like the while loop, we have our done, and we echo our file. However, we want the actual value of file to come out. So what we can do is we go like that, and now it works. So we see we get exactly what we're looking for, and everything is great, everyone's happy, boss is happy, I'm happy, life's good. Okay? So we got this done over here. Now we want to explore a little bit more. So I said that when you have something like this doesn't tunnel it out to standard output. So if I do ls over here, it will actually output it to standard output, which I might not want. So if anytime I want to, I can always do the redirection to dev null, and it will all be gone, and it will never ever see it again. If you want to output as well errors, so I can do 2/dev null, and this will output the standard errors as well to dev null, but I don't recommend that. You typically want to see if you have errors, so you can, at least your user knows that something went wrong. And if you have any diagnostics, it's a lot easier to work with when you actually see the error happen besides your program just having undefined behavior and don't know what went on. So yeah, that's basically my quick tutorial on shell scripting. Hope you guys enjoyed this video, learned a lot. If you have any questions, leave them down below. So just to review, remember how to pass in parameters into your program. You can have different exits, you can have conditional statements, you can have while loops, for loops. You substitute in variables using the $sign character, you do arithmetic expressions using curly brackets, and we have mathematical operations such as the ones like dash eq, dash less than, and so on, so we can see a different list we had over here, like so. Yeah, thanks for watching.